This is Mrs. Bolvin, and this is Goddess of Science Physics, and this is part 2 of my momentum series, and we're going to talk about impulse changes momentum today. Okay, so let's get started. So the main idea of this section is the change in momentum depends upon the force that acts and the length of time that it acts. You're like, wait a minute, we were just talking about momentum being mass times velocity. What the heck is with the deal with the force and time? That's just kind of weird. Well, let's explore that a little bit. Okay, before I get going here, I noticed that there's a nice link that popped up right there. All of the links that you see in this video, there's actually a folder on your Schoology site in the Goddess of Science video lectures that has all of these videos. So if you want to go and watch them, that would be awesome. So impulse changes momentum. For momentum, P, remember this is the chapter of the awkward symbols and the awkward units. For momentum of an object to change, a couple of things have to happen. The first thing is its mass has to change. Oh, okay, well that makes sense. If you divide something in half or you take half of it away, the velocity is going to go faster, obviously. Its velocity has to change. Well, if velocity is changing, that's actually acceleration, huh? As we learned back in chapter 2. Or both mass and velocity have to change. So those are the three ways that momentum can change. So let's talk about these a little. If you have a greater force acting on an object, the greater its change in velocity is going to be, obviously. So if you have one object and you increase the force that you're applying to that object, it's going to accelerate more than if you applied less force. If you're getting a greater change in velocity, that means that you're going to have a greater change in the momentum. So let me say that again. If you have a force acting on an object, and we know that the greater the force, the greater the acceleration is going to be. And remember, acceleration is change in velocity. And one of the ways that you change momentum is by changing velocity. Bigger force acting on an object, bigger change in velocity, bigger change in momentum. Okay, so change in momentum is given its own term. It's called impulse. And this is not like impulsive, like I have an impulse to, have an extra milk at lunchtime. No, that's not the same kind of thing. So impulse in science is the change in momentum. The change in momentum is impulse. Put those two things in your brain equal to each other. The change in momentum is impulse. Impulse is the change in momentum. Now I said that like 4 times, and I'm going to say it again. Here I go. Change in momentum is impulse. Impulse is the change in momentum. Okay, that's 6 times that I've said that. Really, really, really important that you put those two things in your brain, because if I ask you for the change in momentum, you need to find the impulse. Okay, so for a force acting for a long time, you get a greater change in momentum than an equal force applied briefly. If you think about if you play a sport that requires you to hit a ball with a racket, like tennis, or if hit a ball with a bat, you don't start right from, stop and then try to get it to go far. You have to kind of wind up. And the reason that you do that is because it increases the time for the force to act on the thing when you make contact with it. And that increases the change in momentum, which is increasing the velocity. So, factors affecting change in momentum: the amount of force that you're applying. So bigger force, bigger change in velocity, bigger change in momentum. And also the time the force is acting. So if you have a force that's acting for an extended period of time, it's going to have a lot longer to act on that object to change its momentum, as opposed to a force that only acts for a very brief amount of time. Okay, so impulse, the formula, how you calculate impulse is you have the force and the time that the force is acting. So impulse equals force times the time interval. And so, again, this is the chapter of weird letters representing stuff. Impulse is actually represented with a J. Weird, huh? Yeah, I don't understand that one. Although I do understand that I is actually current in electricity, so that's why they couldn't use an I, but I don't know. Anyway, so it's J, kind of weird. And the formula for impulse is J equals the force F times time that the force is acting. So this is another formula that you're going to have in your arsenal of formulas. And here's the weird unit that goes along with this one. It's Newton seconds, because force is measured in newtons and time is measured in seconds. So it's Newton seconds. They don't have a special unit, you know, like a Pascal or a Newton or something like that. For this one, it's just Newton seconds is the unit. Okay. So the greater the impulse exerted on something, the greater the change in momentum is going to be. Why is that? Because impulse is the change in momentum, and the change in momentum is the impulse. So if you have more impulse, obviously you're going to have more change in momentum. So impulse is the change in momentum. There, I've said it another time. And I'll say it again. Change in momentum is impulse. I know I've said it like a bazillion times and you're ready to fast forward this video, but it's really important. So you can say, because impulse is the change in momentum, you can say that force times time, which is the impulse formula, is equal to the change. Now we're talking about the change, not just, you know, the mass times the velocity. It's the change in velocity here times the mass. And we put the little triangle out in front because the triangle is the Greek letter delta, which stands for change in. Okay. So increasing momentum, I'm going to give you some examples here. And again, the video is available to watch. There's a folder of them on your Schoology site. So maximum increase in maximum momentum increase by applying the greatest force for the longest amount of time. Greatest force for the longest amount of time. So this, you could think about this like bunting a baseball. There's literally no wind up when you bunt. So you only want to have contact with the ball a very short time because you want somebody to be able to advance, a runner to be able to advance or something like that. As opposed to winding up to hit a home run, you want the greatest force for the longest time. That's why you don't start out just from stop. You actually start out behind where you think the ball is going to be. So a golfer teeing off and a baseball player trying for a home run do exactly the same thing. When they swing as hard as possible and follow through with their swing, when a baseball player or a golfer is going to hit the ball, they want to hit it as far as possible, they don't check their swing. They don't stop their swing. They let it go all the way through because that means that the force is acting for the maximum amount of time. Okay, force of impact on a golf ball varies throughout the duration of the impact, and I thought this was actually kind of a cool picture. This is some sort of a driver or a wood golf club. And notice what's happening to the ball here. It's kind of flattened out, and what will happen once the ball takes off is it will return to its regular shape. So it's kind of cool. Force involved in impulses usually change from instant to instant. A bat that strikes a baseball exerts zero force on the ball until it comes in contact with it. Well, obviously not. If I throw a baseball across the room, somebody 2 doors down who's not even in the same room is not going to be affected by the baseball that I tossed here in this room. Force increases rapidly as the ball becomes distorted. The force decreases as the ball comes up to speed and returns to its original shape. So a lot of force right off the bat. One of the videos that you can watch it shows super slow-mo of a bat hitting a ball. It's actually kind of a cool thing. And that's probably the video. Okay, so another example. If you're in a car that's out of control and had to choose between hitting a haystack or a concrete wall, which would you choose? So do you want, and really the question is, do you want all of that force to stop immediately, or do you want it to stop gradually? Well, the answer is, you're coming in here, you have a high velocity. You actually want to hit the haystack, because what will happen is it will take a lot longer for you to get through the haystack. The force of hitting that haystack will be spread out over a longer time, which means that the force can be smaller. Even though you have a large velocity, the force is going to be much smaller. If you hit a wall, the force is really big because the time of impact is really, really small. So because those two things are equal to each other, you can kind of control how much force you want to feel when you're driving in that car. This is exactly the same reason why you wear a seatbelt, because you want to, and we have padded dashboards because we want to increase the time that the impact force is acting, so it decreases the force, so your face doesn't become part of the windshield or part of the dashboard. If the change in momentum occurs over a long time, the force of impact is small, and that's how you survive crashes in cars and vehicles. So there's a lot, and we also now have airbags. When you hit something, the airbag deploys. That increases the time of impact, which decreases the force on you. So all kinds of car stuff in this chapter for sure. So here's a nice little visual. If the change in momentum occurs over a short time, the force of impact is really, really large. So when we have the same velocity, if we hit a brick wall, the time is so tiny, the force that's going to occur on the car and the occupants of the car is going to be really, really huge, and that's when people have serious, serious injuries in car crashes. Okay, so I apologize that this all came in at once. When you're hitting either the wall or the haystack and coming to a stop, the change in momentum is exactly the same, because you had the mass of the car, you had the velocity that you're going, and the change in the velocity is going to be exactly the same. So the change in momentum doesn't change, but what you do want, you want to change the force that's acting on it. So we do that by changing the amount of time that that force is acting. So equal impulse doesn't mean the same amount of force or the same amount of time. It means the same amount of force times time. To keep the force small, we extend the time. That's a nota bene. Pay attention to that. Since impulse is change in momentum, and that the change in momentum is going to be exactly the same, the only two things that we can control somewhat is the time that the impact is going to take place and the force. If you have a big time, a long time that the force is acting, the force can be really tiny. If the time that the force is acting is very short, then the force has to be really, really huge. Okay, when you extend the time, you reduce the force. Kind of just said that. Padded dashboard in your car is safer than a rigid metal one, for sure, because it increases the time of impact. Airbags, for the same exact reason, it increases the time of impact, so it can decrease the force. Doesn't decrease the impulse, it doesn't decrease the change in momentum, but what it does do is increasing the time decreases the force. To catch a fast-moving ball, extend your hand forward and move it backwards when making contact with the ball. If you've ever watched a big league or even a high school catcher catch a ball, they start with the glove out in front of them and then pull it back as the ball is arriving, because if you're catching a 90-mile-an-hour pitch, you don't want a very short amount of time that force is going to be acting on your hand. You want to extend the force so that you can extend the time so that you decrease the force. When you jump down to the ground, you probably have done this. Bend your knees when your feet make contact with the ground. And this is exactly the same thing. When you're jumping off something, you need to extend the time that impact is acting, the force of impact is acting. And if you bend your knees as you hit the ground, it's going to increase the increase the time of impact, which decreases the force. If you don't bend your knees when you're jumping down from any kind of height, you might run the risk of having so much force that it breaks through the bones in your legs or your ankles or your feet. Impulse provided by a boxer's jaw. This one's kind of an interesting one. If you ever watch professional boxing or even amateur boxing, one of the things that they do is when a punch is coming at them, they start moving their head backwards because that increases the time of impact, which decreases the force. Rather than moving into the punch, because when they move into the punch, then the time is very short and the force is really big. So if you are on the attack, you want to look for a time, you want to try to make your punch time when the person is moving toward you, not when the person is moving away from you. Is a glass dish more likely to survive if it's dropped on a carpet rather than a sidewalk? Well, if it's dropped on a sidewalk, it pretty much has a very short time of impact, which means the force is going to be great. So probably it's not going to survive, but is carpeting enough? There's a video that you can watch in the folder on the Schoology site that shows kids dropping a glass from as far up as the top of their house, and it doesn't break when it lands on the carpet that's below. And there's the video link if you want to watch it. The carpet has more give, which means that it increases the time of impact, which decreases the force. Time is longer hitting the carpet than hitting the sidewalk, so smaller force results. The shorter time hitting the sidewalk results in a greater stopping force. You want to increase the time to decrease the force. Okay. Well, that was a lot. A lot of examples. Hopefully you understand impulse and change in momentum a little bit more. But remember, impulse is the change in momentum. Thanks for joining me. Have a great day.